Okay, so hello people. So today we'll be solving LeetCode daily question, that is 1921, eliminate maximum number of monsters. In this we'll be giving a video game where we'll be defending our city from n number of monsters, and we'll be given a zeroth index integer array distance of size n, where distance I will be the initial distance in kilometers of the ith monster from the city. And then what will be given, the monsters will walk towards the city at a constant speed, and the speed of each monster is given to you in an array speed of size n, where speed I is the speed of ith monster in kilometers per minute. Okay, and we'll be having a weapon that once fully charged can eliminate a single monster. However, the weapon takes 1 minute to charge. The weapon is fully charged at the very start, and what we'll lose the game that whenever any monster reaches our city. And if a monster reaches the city at the exact moment the weapon is fully charged, it will be counted as a loss. Okay, and the game ends before you can use your weapon. Okay, so in this what we have to return the maximum number of monsters which we can eliminate before I lose, or the n number or n number of monsters that I n if I can eliminate all the monsters before they reach the city. Okay, so now let's move towards the explanation of the test cases. The first test case, we are given that the initial distance of the monsters are 1, 3 and 4 respectively, and they are moving with the speed of 1, 1 and 1. Okay, so just okay, so yeah, we'll be given a speed array, and the speed of ith monster is 1, and second monster is also 1, and third monster is also 1. Okay, so what we can conclude that initially our weapon is fully charged, so it will be destroying the first monster as it is at a distance, and after 1 minute our okay, like post 1 minute our weapon will be recharged again. So like, let's say this is the battery and it will be recharged again. Sorry for the drawing. Yeah, and it will be recharged again. So, and after the 1 minute, as the speed of ith monster is 1 kilometer per minute. Okay, so and then the array will be like this will be destroyed, and this will be 2, and the fourth one will be 3, as the both are as these two will be approaching. So after 1 minute we can also destroy this. So at the end what we'll be having after 1 minute, we'll be having this will be destroyed, this monster will be destroyed, and here we'll be having 2 kilometer of distance. Okay, and as it will be the third minute, so our machine will be fully charged, and this is still far away from the city, so we can also destroy this monster. Similarly, if we go for the next next example, in this the distance is 1, 1, 2 and 3, and the speed is again 1, 1, 1 and 1. In this we'll be only able to destroy one monster, because like, let's say this is okay, let me just add, let's say this is the city, and we are having two monsters at the distance of 1 and 1, and other two are having at the distance, let's say 2, and I guess the third one is at the distance 3. So if we fire the machine from here, the weapon from here, it will be able to destroy only one monster, and the other monster will be able to enter the city. So maximum number of monsters which we can destroy is only one. Okay, and whenever this monster will be reaching the city, we'll be losing the game. Similarly, in third test case, what we can see is we'll be given the distances as 3, 2 and 4, and the speed of them will be 5, 3 and 2. Okay, so as here also we'll be able to destroy only one monster, because the speed we'll be able to destroy the third monster only because our machine will be fully charged. But after for the second monster the speed is 3. So and after just a minute it will be covering okay, let me just draw, let's say this is the city again, and first we are having a monster at a distance of 3, then we are having a monster at a distance of 2, I guess, and yeah, the third one is at a distance of 4. Okay, so if when we'll be firing a weapon, we can only destroy this monster, and if we try to destroy, let's say some other monster, let's say if we try to destroy this monster, these are moving with the speeds of, I guess, 5, 3 and 2. Okay, 5, 3 and 2. Okay, so let's say we destroy the third monster first. This is can be the one possible answer. If we destroy this monster, so after 1 minute this monster will be able to enter this city, because its speed is 3 kilometers per minute and it is only 2 kilometers away. Okay, So this is how we can destroy only one monster. The other test case, okay, this is for the second. I am just marking. This is for the third. Let's say this is ith test case, and let's say here. Let me just erase this. Yeah, here we'll be creating for the third second test case. Let's say we destroy the second monster. That is, let's say, which is at the distance of 2, and this is at a distance of 4. Okay, so here is the weapon, and if we destroy okay, the speeds are also, let me just mention that 5, 3 and 2. Okay, if we destroy this monster, so and after 1 minute, as our weapon will take 1 minute to fully charge, this monster will be able to enter the city, because after 1 minute it can cover 5 kilometers, and the distance between the city and monster is just 3 kilometers, so it can easily overlap and enter the city. So here again we'll be able to to destroy only one monster. Okay, so this is how what the question is asking, we have to solve. And now let's move towards the pseudocode for this. What we'll be doing, we'll be implementing a priority queue. I'm just writing it PQ, okay, of let's say monsters. And in this, what we'll be storing the time taken by every monster to reach the city. Okay, let's say for, let's say, and I equal to 0, I less, okay, just let me just write the pseudo. Yeah, I equal to 0 to I less than n. What I'll be doing, I'll be adding monsters dot add dist of I by speed of I. So basically, speed, as you all know, distance is equal to speed into time, so time will be equal to distance upon speed. Okay, so I'll be just adding the time taken by every monster to reach the city. Okay, then what I'll be doing, I'll be initializing a variable, let's say answer, which will be containing the total number of monsters which we can add. So at initially our answer will be this answer variable, let's say this is the time taken by the machine, how many time we can reload the machine. So firstly we don't need any, because the machine is fully charged. Okay, so while not monsters dot is empty, and okay, and we'll be checking that if heap dot remove will be less than or equal to the answer. And answer, okay, sorry, answer, here at this point we'll be breaking out of the loop, and we'll be just returning the answer. Okay, oh, okay, here we'll be need to increment the answer. Okay, so like while monster is not empty, we'll be adding all the, and this heap dot remove function, what will basically does is that it will be checking the time for every monster. Let's say we are having the time taken by the monster to reach the city is 2, and we are having that our machine is loaded only once. So as 2 will be not less than or equal as 2 will be greater than 1, so it will just do answer plus plus, as we know that we will be able to kill the monster. But in the other case, let's say something like 1 less than 2 happens, so okay, let me just 1 less than 2 happens, so we'll be breaking out of the loop. Okay, so yeah, now let's move towards the coding window for this. And just a second. So yeah, let's continue with the coding part, and let's declare a priority queue of double, basically because the speed distance amount speed might come in a double value. Let's say monsters, uh, and this will be equal to new priority queue. And then what I'll be doing for and I equal to 0, I less than test dot length I plus plus, I'll be just heap okay, monsters dot offer, let's convert it to typecast it to double dist I by speed, okay, sorry, by speed Right. Okay. So now let's declare a variable answer that will be equal to 0, and while not monsters dot is empty. So what I will be doing that if monsters dot remove is less than or equal to answer, I'll be just breaking out of the loop, and otherwise I'll be doing answer plus plus, and at the end I'll be just returning the answer. Okay. Okay, I guess I made a mistake. Um, we'll just go through the code once again. Dot remove less than or equal to answer. Okay. Not okay, not operator. But I don't think that this should make any difference. Oh yeah, that's what I was saying. In this child by speed I just typecast this to double. I wish that the typecasting is done properly. Oh, okay. There was also the issue with the brackets over here. Now let's submit it. Now, and yeah, and it gets accepted. Okay. So this was it for today. Thank you for watching.